How are you moving around in your city you live in? By rickshaw, by bicycle, on foot, bus, matatu, train, or even by boat? Or could it be a combination of those? Similarly, the collection and transport of fecal sludge uses a variety of technologies based on the local context. For example, how would you collect and transport fecal sludge from a dense neighborhood to a treatment plant? Following this module, you will be able to explain why urban areas rely on a range of collection and transport technologies, name existing established technologies for collection and transport, and discuss which technologies are appropriate based on the local context. Urban areas include different physical and socio-economic realities influencing fecal sludge collection and transport. Among others, the sludge characteristics, access, the transport distance, and economic status are important for collection and transport. For example, in my city of Kampala, Uganda, examples of our on-site infrastructure include planned, middle, and high-income areas with good road infrastructure, which are mostly connected to the sewer or septic tanks with a low solid content. Unplanned, densely populated low-income areas with poor accessibility and fecal sludge from pit latrines has got a very high solids content. And peri-urban areas with a low population density and therefore long transport distances. These different realities explain the large range of collection and transport technologies that exist and will be introduced in this module. Collection technologies can in general be categorized into manual, manually operated mechanical, and fully mechanized technologies. Manual collection with buckets or shovels is often unsafe and unhygienic. Frequently, it involves the workers entering directly into the on-site sanitation technology. However, manual collection can be an important part of providing fecal sludge management services, especially for the poor. In addition, it can collect thick sludge that is difficult to collect with mechanical technologies. Implementing minimum standards and their enforcement, licensing, training, and capacity development can improve the safety and hygiene of service providers and the community. For example, as shown here in Lusaka, Zambia, where workers wear protective boots, gloves, and face masks. The GALPA shown in action here in Kenya is one manually operated mechanical collection technology. In comparison to manual collection with shovels and buckets, this can increase the safety and hygiene by preventing human contact with fecal sludge during collection and increase the amount of sludge that can be collected per day. With a GALPA, the sludge is pumped out manually by moving a plunger up and down. The plunger contains a valve which opens when the plunger is moved downwards and closes when the plunger is lifted upwards, moving the sludge towards a collection vessel. Manual collection technologies need to be combined with appropriate transport technologies to ensure sludge reaches a treatment plant. Commonly, manually collected sludge is pumped into drums and transported by trolleys, carts, or on pickups, as shown here. These barrels commonly have the size of 100 to 200 liters. To allow sludge collection in these areas, smaller trucks, shown here, commonly referred to as vacuum tags, have been developed. The common sizes of these tanks are between 0.5 and 2 cubic meters. The technology considered for transport of manually collected sludge must take into account the distance to the next treatment plant. For example, carts are at most able to transport the sludge for a few kilometers. Transfer stations, as a way to improve sludge logistics, are covered in another module. Mechanical collection technologies are pumps driven by electricity or fuel. These technologies can pump large amounts of sludge per day than manually operated technologies. Pumps that are mounted on tractors and trucks, as shown here, are the most common mechanical collection technologies and allow transport of the sludge over long distances. The vacuum pumps the sludge through a hose into a tank. Common sizes of these tanks are between 2 and 20 cubic meters. Vacuum trucks often have difficulties accessing on-site sanitation technologies that can only be accessed through narrow roads and alleys. In summary, different sludge collection and transport technologies have different opportunities and challenges. Based on sludge characteristics, economic status of the customer, access and transport distances that can be covered, it is up to you to select one or several technologies for your neighborhood or city. Manual collection and transport technologies can collect sludge with a high solids content, such as from pit latrines, and can access narrow lanes. However, these technologies commonly only collect small amounts of sludge, and transport of this sludge to a treatment plant can be a challenge. This can result in the discharge of the collected sludge into the urban environment. Mechanical collection and transport technologies are often only appropriate for sludge with a low solids content. In addition, access of on-site sanitation technologies can be a challenge. In general, per volume of fecal sludge, manual collection and transport are more expensive compared to mechanical technologies. This is due to the time and work spent accessing the on-site sanitation technology and the low volumes of sludge collected and transported for treatment. This is an inequality for the urban poor that should be considered. In this module, we have learned that a number of different collection and transport technologies are used in urban areas, corresponding to different physical and socio-economic realities. In addition, a number of different collection and transport technologies were introduced that are appropriate for different local contexts, considering accessibility, transport distance, and service costs.